Species distribution modeling, SDM, is a set of techniques used to predict the geographic distribution of species based on environmental variables. These models are widely used in ecology, conservation biology, and climate change research. Here's a detailed breakdown of how SDMs work mathematically and how they could be adapted to model something unconventional like the existence of teacups. Mathematical foundations of SDMs. Environmental variables. SDMs typically use environmental variables such as temperature, precipitation, elevation, and soil type to predict species distributions. These variables are often represented as raster layers in a geographic information system, GIS. Presence/absence data. The model requires data on the presence and sometimes absence of the species at various locations. This data is usually collected through field surveys or from historical records. Model types. Generalized linear models, GLMs, these models use a linear combination of environmental variables to predict the probability of species presence. The logistic regression model is a common type of GLM used in SDMs. Generalized additive models, GAMs, these models extend GLMs by allowing nonlinear relationships between the response variable and the predictor's point 39. Machine learning models. Techniques like random forest support vector machines, SVMs, and neural networks can also be used. These models can capture complex, nonlinear relationships between environmental variables and species presence. Model evaluation. The performance of SDMs is typically evaluated using metrics such as the area under the curve AUC, of the receiver operating characteristic ROC, curve true skill statistic TSS, and Cohen's kappa. Applying SDMs to model the existence of teacups. While SDMs are traditionally used for biological species, the same principles can be applied to model the distribution of any object, including teacups. Here's how it could work. Define the object. Clearly define what constitutes a teacup in the context of your study. This could include specific characteristics like size, shape, and material. Collect data. Gather data on the presence of teacups at various locations. This could be done through surveys, historical records, or even social media data, e.g. geotagged photos of teacups. Select environmental variables. Identify environmental variables that might influence the presence of teacups. These could include human population density. Higher density might correlate with more teacups. Proximity to urban areas. Teacups are more likely to be found in urban settings. Cultural factors. Certain cultures might have a higher prevalence of teacup use. Economic indicators. Teacups might be more common in areas with higher income levels. Model training. Use the collected data to train an SDM. For example, you could use a logistic regression model. Model evaluation. Evaluate the model's performance using appropriate metrics, e.g. AUC, TSS. This will help you understand how well the model predicts the presence of teacups. Prediction. Use the trained model to predict the probability of finding teacups in areas where you don't have data. This can help in understanding the spatial distribution of teacups and identifying areas where they are likely to be found. Conclusion. Species distribution modeling is a powerful tool for predicting the geographic distribution of species based on environmental variables. By adapting the principles of SDMs, you can model the distribution of any object, including teacups. The key steps involve defining the object, collecting data, selecting relevant environmental variables, training the model, evaluating its performance, and making predictions.